Okay, so here's our 13.3 solving absolute value equations video. We've already talked about some of what you need to know for absolute value. So let's just finish up and talk a little bit more about solving a few different types of equations since we only did like one or two together today. So some things to remember: if absolute value equals a positive number, we learned today that that means there are going to be two cases. If absolute value equals 0, that means you're only going to have one, and we didn't even call them cases today. That's probably not good. We call them solutions. So there's two solutions. If it equals 0, there's only going to be one solution. And if it equals a negative number, there's going to be no solutions. And the other note that we took is that we must remember to isolate or get the absolute value on its own first before we do any additional work. So we have to make sure that's our first step. There's a little analogy that I found that I'm going to talk with you about prisoners, visitors, and being in jail. So let's look at that real quick with an example. Okay, so we want to think about absolute value as jail bars. So the absolute value bars are jail bars. And the problem on the inside, we want to think about this as being prisoners that want to get out. Now, you can pause this and read what is written here, but I'm just going to explain the exact same thing. Anything on the outside of the absolute value bars, but in the jail, we're going to call these visitors. So this 2 on the outside is a visitor. And the idea is that the prisoners want to get out, but before they can get out of the jail, they have to wait until all their visitors leave. So to get rid of that means we have to get rid of any visitors first. So in this example, they chose to divide by 2, remember, because we're not allowed to distribute. So then we came up with this new problem right here. All right, so I've got my prisoners that are in jail, 3x minus 1, it's in jail. And now it has the option, all their visitors are gone, so they can get released from jail. And the idea is that they have two options. You know there's supposed to be two solutions, so they have two options. They can either choose to be good, so we call this one good because it equals positive 3, or they can choose to be bad, right? They have the freedom to make that decision. If they're going to be bad, that means it's going to equal negative 3. Notice that now the absolute value bars are gone because they're out of jail, right? These are like their two scenarios when they're outside of jail. So once they're out of jail, now they have the choice. They can either be good, remember, notice they're out of jail, so they can be good, positive 3, or bad, negative 3. Well, now that they're out of jail, we can just solve what this whole scenario looks like. So just go ahead and get this copied in your notes, but notice now we have two solutions, either x equals 4/3, because 4 does not divide by 3, or x equals negative 2/3. And that is what we wanted, that they had two solutions. So this is an example of two solutions, kind of thinking about our jail scenario here. So let's look at maybe some other types of problems and see what we might run into. Okay, so remember, we need to get our absolute value bars by themselves, right? We need to get our prisoners free, but first, their visitors have to leave. So I'm just going to highlight for us so that we can see our visitors. All right, that's going to be my negative 5 and my positive 2. We have to get them to go away first so that my prisoners can get free. So to get rid of my visitors, I'm going to subtract 2 from both sides. Negative 5, x plus 1 equals 10. And then I need to divide by negative 5, right? So divide both sides by negative 5. And I'm left with x plus 1 equals negative 2. Now notice, all my visitors are gone, so now we can talk about getting out of jail. Well, this would mean, you can kind of think about it like this way. My prisoners are in jail, and they're still bad. So if they're bad, they have no options. They can't even get out of jail if they're bad. You can also remember that because this is negative, this is no solution. So automatically, you just jump to a point where you're going to say there will be no solution, right? They can't get out of jail because even inside of jail, currently inside of jail, they're still bad, and that's a problem. Okay, one more example with our little jail scenario here. So my prisoners are 2x minus 4, and we've got some visitors here that we need to get rid of before we can talk about them getting out of jail. So subtract 1 I've got 3/5 2x minus 4 equals 0. And then this is something I just wanted to show you. I don't know if you remember, to get rid of a fraction like this, you can divide or we can multiply by the reciprocal. That's something that might be a little bit new to you, but when you multiply by that, I'm just kind of giving you a little side note here. When you multiply by that, you get 8/8, which is just 1. Those things cancel each other out. So really, all of this cancels itself out. We're going to multiply by 5/3 on the other side. And anything times 0 is just 0. All right, so we've got equals 0. And now we can remember that if it equals 0, that means we're only going to have, this is just a reminder, so reminder, we're only going to have one solution. So you can kind of think of it like, if they weren't good or bad on the inside, well, then they aren't really probably going to be good or bad on the outside. So that means they're going to get out of jail, and their only option is to be 0. All right, so then we're just going to solve that. 2x equals 4. X is going to equal 2. So they only have one option here, x equals 2. All right, I really hope that thinking about it like jail and having your visitors leave and then being good or bad outside of jail maybe helps you remember all the steps to this. But we'll work on a few tomorrow and really make sure you've got this before we move on.